Hello boys and girls, I am Miss Martina Archer Semple, and for science today we would be looking at forces. So at the end of this lesson, you would be able to know how forces are measured, identify force measures, know to convert mass to force, and become aware of the effects of increasing and decreasing forces. Force, what is force? A force is a push or pull movement. When we push objects, they move away from our body. When we pull objects, they will move towards the body. The force has magnitude and direction. Magnitude refers to the amount of force that you applied to push or pull the objects, how hard or easily the force is. Direction refers to north, south, east, and west. We cannot see force, but we can see its effects on objects. A force can be in the form of a squeeze or a ring or a twist. The unit used for measuring force is known as Newton. It's represented by N. We can make force by lifting objects, using magnets, turning objects, pulling objects down. Forces can do the following. Force can make objects start to move. Force can make things change their shape. Forces make objects slow down or stop. Forces make objects change direction. Right, so forces can do all of these things. So we're going to look at types of forces. The different types of forces are frictional force, gravitational force, magnetic force, upthrust force, and surface tension. When we talk about friction force, friction is a force which opposes motion or movement between two surfaces that are in contact. Friction can be produced by rubbing two surfaces together. Examples of some ways how we can produce friction are by rubbing our hands together, rubbing the pen on the desk, or scratching a match, scratching a part of your hand, etc. Friction will produce heat when surfaces are rubbed together. Now, the amount of friction between two surfaces will depend on the amount of force pushing an object, the roughness of the surface. Objects that weigh more, which are heavier objects, will produce more downward force than objects that weigh less, so lighter objects. Rough surfaces will produce more friction than smooth surfaces. Smooth surfaces will have little friction. We can represent force by using an arrow. Now, longer the arrow means that more force will be needed to push or pull the objects. Shorter the arrow means less force will be needed to push or pull the object. We can reduce friction by using oil, wax, or grease. Polishing surfaces using Ball bearings make surfaces that rub against each other smoother. We can increase friction by making surfaces rougher, increase the force used for polishing surfaces. As we continue to talk about friction, friction can be both useful and harmful. Useful refers to the advantage, which is positive effects. Harmful refers to the disadvantage, which are the negative effects. Some advantages or positive or good things of friction are: it helps us work. It helps moving object to slow down or stop. It can cause a match to light. Some disadvantages, or we say negative or bad things of friction are: it weakens parts of the vehicles, example, the tires, the brakes, etc. It can cause the bottom of shoes to be worn out. It can cause match to light. Those are some negative or bad things of friction. Now, in conclusion, a force is a push or pull upon an object, resulting from the object's interaction with another object. Whenever there is an interaction between two objects, there is a force upon each of the objects. When the interaction ceases, the two objects are no longer experience the force. Forces only exist as a result of an interaction. Direction refers to north, south, east, and west. We cannot see force, but we can see its effects on objects. A force can also be in a form of a squeeze or twist. The unit used for measuring force is Newton. Magnetic force. Magnet is a force which attracts objects. Magnets attract materials that are made of iron or steel. Substances that attracts the magnets are called magnetic substances. Some examples of magnetic substances are razor blades, pins, clips, needles, etc. Substances that do not attract the magnet are called non-magnetic substances. Some examples of non-magnetic substances are bricks, paper, gold, copper, rubber, pencils, pens, rulers, etc. Electric forces exist among stationary electric charges. Both electric and magnetic forces exist among moving electric charges. The magnetic force between two moving charges may be described as the effect exerted upon either charge by magnetic field created by the other. Now let us look at the types of magnets. The two types of magnets are permanent magnet and temporary magnets. Magnets have different shapes. For example, the cylindrical magnet, the horseshoe magnet, the U-shaped magnet, and the rectangular magnet. Yes, magnets have different shapes. When we talk about permanent magnets differ from temporary magnets by their ability to remain magnetized without the influence of a nearby external magnetic field. Typically, permanent magnets are made from hard magnetic materials, where hard refers to a material's ability to become magnetized and remain magnetized. Steel is an example of a hard magnetic material. There is also a magnetic field that's generated by the orbits of the electrons as they move about the nucleus, so the magnetic fields of permanent magnets are the sums of the nuclear spins. The electron spins and the orbits of the electrons themselves. Many permanent magnets are created by exposing the magnetic material to a very strong external magnetic field. Once the external magnetic field is removed, the treated magnetic material is now converted into a permanent magnet. What are temporary magnets? Temporary magnets, unlike permanent magnets, temporary magnets cannot remain magnetized on their own. Soft magnetic materials like iron and nickel will not attract paper clips after a strong external magnetic field has been removed. One example of an industrial temporary magnet is an electromagnet used to move scrap metal in a salvage yard. An electric current flowing through a coil that surrounds an iron plate induces a magnetic field that magnetizes the plate. When the current flows, the plate picks up scrap metal. When the current stops, the plate releases the scrap metal. Let's now look at the difference between the temporary and the permanent magnet. Temporary magnets do not have the ability to retain their magnetic force on their own, while a permanent magnet always retain their magnetic field or their magnetic force. Temporary magnet requires another magnetic field to have power. The permanent magnet do not require force from another magnet to have power. The temporary magnetic materials are considered to be soft. Permanent magnetic materials are considered to be hard. Temporary magnets able to function through magnetic force or electric current stops working in the absence, while the permanent magnets, usually created with another strong magnetic force, the magnet becomes permanent as a result. Let's now look at what are some natural magnets. Natural magnets are what led to the original discovery of magnets. Magnetite is one of the most common metals that is considered a natural magnet. Magnetite is a metal whose atomic construction is easily magnetized by simply being in contact with other metallic objects. The Vikings and the Chinese used magnetite in their first compasses. Now let us look at electromagnets. Electromagnets are created by running an electrical current through a conductive metal. An electrical current causes the rapid movement of electrons, which creates a magnetic field. Electromagnetic fields can be created by running an electrical current through any metal, including non-ferrous conductive metals. Okay, boys and girls, I hope you would have learned something about magnetic force and can define magnetic force. Also, identify types of magnet. I am Miss Martina Archisemple saying bye for now.